Today we have the oral exam for the computer graphics course. For those who are not part of the class, you're going to see teams are going to be presenting their work on their final project. So without further ado, the stage is yours.
Hey everyone, so as some of you probably know, my name is Dillon Matchett. So I'm going to be talking to you guys today a little bit about biome simulation, which is what I did my project on. So I guess first question, real quick, how many people have played Minecraft before? Well, that was easy. All right, cool. So I basically don't need to do my presentation then, because that's basically what I did. So we're going to start with actually talking a little bit about some of the theory behind how you generate nice looking biomes, or simulate nice looking biomes. The main idea that you use is noise functions. Has anyone here worked with noise functions before? One of the groups mentioned them. But, so basically, noise, I'm going to mess up dates if I try and remember them. Someone came up with a really great noise function called Perlin noise, which was not copyrighted. This is an algorithm. The algorithm for Perlin noise is pretty slow. It's not polynomial, which is kind of lame if you're into that sort of thing. But it's really good because it creates very natural, they're called height maps in 2D and 3D. So in 3D, you'll get a 4-dimensional height map, basically. And in 2D, you'll get a 3-dimensional height map. So if you have a 2D Perlin noise map, and you give it an X and a, let's say, Z coordinate, it will provide you with the Y at that position. If you have a 3D Perlin noise map and you provide it with an X, Y, and Z, it will give you a W at that position. So 3D maps usually aren't used for generating 4-dimensional landscapes. They're usually just used for if something changes over time. They're also really good if you need different seeds for the same noise function. So I have multiple maps and they're all based on the same noise function with the same random seed passed in. And I just use 3-dimensional maps at a set z-plane to generate different unique height maps which aren't relying on one another. But they're still just basically like the third coordinate of a 2D height map, since they're on a fixed plane. Yeah, so the basic idea is, in a game like, say, Minecraft, you use these noise functions to generate heights, and also to somehow provide you with a nice way of going between biomes. So I'm doing a very simple way here, where I go between. So I go between on my X and my Z, the negative of my map size and the positive of my map size, because it's double. It's just whatever. And I keep track of 3 different maps, basically. 2 are based on noise, 1's based on random chance, because, well, I'll get into that. So the idea is, we have a very, very tiny noise function that we're going to put in a holder for each case. And that's going to do my biome generation. And since we want our biomes to be quite large, we make it so we very slowly progress over the map. We divide our values by 10, as opposed to having each value go to 1. Or have each value be a step of 1. We use a 10th instead. And like I said, we just use a 3D map with a random, I just picked 580 out of a hat. It doesn't actually matter. Since we're passing in our random seed elements, we can't say anything of value about that. So yeah, and then based on our holder, we have values which are possible biome options. So if, and that's relevant. Our Perlin or simplex noise, which is a faster version of the algorithm, which is what I'm using, goes between, this particular one goes between -1 and 1. That's where your values go between. So based on our value, if it's less than -0.9, then we're in a mesa biome. And so we push mesa, which is just a color. It's a color vector plus some other stuff, like a, basically it's reflectivity as well is passed, as well as we push to a height map, our other simplex noise function, divided by something and adding other things just to make the heights look really good. Because we get this random value between -1 and 1, and then we want to modify it. Because mesa, and if you guys know what mesas are, they're basically in the desert, very large rock formations, basically. So we want those to be much higher than, say, sand. So we add this lovely 0.5 if we're in a mesa biome. All of this together has a really cool effect of, since we're using noise, which blends very nicely, we'll get very natural transitions between biomes and very natural heights within biomes and beside biomes as well, which is pretty cool. The more complicated way to do this, which I was explaining to one of the groups earlier, and it's really neat, is if you don't want to use the simpler way, which I am, of just checking to see where the value is, and based on that, deciding on a biome. Another cool way is you can actually, and I'm pretty sure Minecraft does this now, they didn't used to, you can have a temperature and humidity height map, which you generate, and then based on the temperature and humidity at any point, you then decide on the biome, which is pretty neat. And not a lot more work, it's just not really relevant for this class, since it's just nature stuff. But yeah, it's pretty cool, and it's very neat to actually look at the, I don't know if you can get them out of Minecraft, but I worked on a project that was doing voxel-based stuff a couple of years ago. And some of the heat maps and humidity maps and stuff that we were generating were really cool to look at, and just the effects they had. Yeah, so, I mean, the only other thing worth noting here is I have one other feature on my maps. I generate trees randomly as long as I'm in a green biome or a grassland/forest biome. There's just a random chance of getting a tree, which is what this pushing 1 does. It flags that on that point on the map you would have a tree. The reason that we do it randomly instead of with noise functions is, again, noise is very smooth. It goes to heights and then drops. So if we did it at a % chance of getting trees, then we'd get clumps of trees as opposed to like a distribution, which is not normally how trees grow, last I checked. So yeah, we just kind of do a randomization instead. So this is the main core of my code. This is like the neat part, because again, this is basically how Minecraft works on a smaller scale. So I can kind of show what I've done now. Hopefully yeah, cool. So this is basically my thing drawing at an awful frame rate, because there are a lot of assets that all are completely unique, so they all need to be drawn separately. This could be offloaded to the shader, but it would require a lot of low-level calls, since literally almost all of my code would then be done on the graphics card. Yeah, so the basic idea though is, since I'm getting an awful frame rate and not even showing a lot of a map, I've got a projection of part of the map. We can move around said projection, take a look, and we can also travel. So here we go, we've got some water, and you can see here there's some grassland with, again, sparse out trees, awesome looking trees. From water, here we have ice, which then blends into some snow. We're getting some specular light from the sun, which is off in the distance. That is another thing. One of the big things I wanted to do with this project was to have some cool interactions with light. So to do that, I have a point like sun, which moves across the map. Even though I was only drawing a little bit of the map, I still wanted to get really cool effects from the sun. So since the sun isn't a lot to draw, I draw it all the time, and I just keep track of where it is relative to where I'm rendering. So we can see if I start to move this way, the sun actually comes closer, as you would kind of expect. So yeah, and it travels normally as well, and all of the lighting is based off of those, I guess, offset coordinates for the sun. So we can kind of, when we draw, That's kind of, I guess, worth mentioning. We do a first pass of our height map, where we decide on what biome it is based on our biome map and how tall it should be based on our height map, which I showed you how we filled in code. From there, we draw our biomes except for water. So we do that, we draw all of our biomes. We then, if it's a grassland and there's a tree on our tree flag, on our tree map, we also draw trees, which is a separate function, but it's pretty simple, it's just 2 cubes, with one of them having a tight top. We then do a secondary pass where we do water, and the reason we do that is so that we can guarantee that our water will blend properly, which, I mean, you can kind of see that this water, you can see the forest through it. The problem being that if we don't have, if we don't draw our water last, then we're doing it in basically an array format. So we draw our blocks like this. So down a row, and then across one, then down a row, then across one. So our problem is if we get blending on some cases, but not others. So the way I think it works is if we had like water here, and then block here, and block here that aren't water. This one and this one would show up in the water because of the way blending works, because they were already rendered when we put our water in. But if we spun the camera around to face this way, this water block wouldn't properly blend on this one because this would have been drawn afterwards. And we still have all of our optimization stuff for not drawing invisible faces for our normal blocks. Just our water is the only thing that skips that. So yeah, we do a second pass for water just to get rid of that issue. And then yeah, that's basically it. We just generate all of our light stuff. I played around with getting shadows working, but I'm already getting 6 frames without rendering a 6-faced texture for point light shadows. So that was scrapped once I was debugging. But yeah, hold on, I'll refresh and I can kind of show that you can get some pretty cool effects with specular light and stuff. One other thing that's pretty neat is I added a reflectivity mark to all of our, oh, that's Mesa, by the way, that's, yeah. Yeah, so one thing I added is each surface actually has a certain amount of specular light that it reflects. So, I mean, the sun pointing directly at grass isn't very reflective. The sun pointing directly at ice is. So that's just kind of a neat extra. Same thing like Mesa is very reflective, while sand is kind of, but not as reflective. So yeah, it just, yeah, it's basically the project. Light properly tracks, even if it's far away. Lovely glare off ice. Yeah, just biome generation. Right now I'm using a 200 by 200 map. If you get to the edge, which I guess I can show. Yeah, you just kind of, it just stops drawing, basically. But yeah, I don't know, there's not really much left to say, I suppose.
Why did you get the better FPS when it was moving?
Oh, what happened was I stopped having assets to draw. Yeah, that's why it bumped up. And then it was still, since it takes an average of the last 2, it took a while to normalize back down. But yeah, it'll steadily drop once I.
So this happens because you're on the edge? Otherwise,
yeah, I mean,
it's not because of the water?
Well, because the way it works is, in my code, I calculate, I basically do my x values and my z values from 0 to 2. I have basically a 0 to 2, and then that 2 is divided by the width I want for my cubes. So I think I have it at 0.15 right now, which doesn't work out evenly, but all my math's off like greater than, so and equal or less than, so it's fine. But yeah, so the cubes themselves have a width, and then it's however many fit on the map with that width for 0 to 2. and then from there I calculate where their actual value would be on the map. But if I'm off the map, I just don't draw anything. It's not that I draw it and then throw it out. The logic's just in there to say like, oh well, I mean, that's not part of the map, so there's nothing there to draw. I'd probably also get array and X out of bounds issues if I did.
Did you get any backface calling working there?
Yeah. No. So the way I actually do it is when I draw out and block, I figure out the minimum. There's basically a minimum height value that I calculate, where the minimum height is the lowest of all of the blocks around it. Since let's say we have 3 blocks in a row. Oh god, I'm gonna mess up drawing this. And then 1 down here. Yeah. So yeah, and this just go down. The problem is I have to render a certain amount of this face because it has to show up here, right? So yeah, you basically take the minimum of all of the ones around it and the bottom of the bottom of it itself. Or sorry, I guess the top value. Because if everything around it's taller than it, it can just be flat. It doesn't have to have any sides. But yeah, there is the chance that if it's taller than at least one face around it, you do have to render a certain amount of the square to make sure that, yeah, you can. So these in here show up. Yeah, but I mean,
So you
and that
optimize
actually,
out the rest.
sorry?
So you optimize out the rest.
Yeah, all of the rest isn't drawn. Again, the real problem is it's just there's a lot of passes. Like every time I draw a cube, I have to pass the full color matrix, and I have to pass I still have to pass a vertex set.
If you had different shaders for different colors, would that be a way to optimize this?
Yeah, there's a couple of ways I was playing around with. One of the ones was, I mean, that would work. The main issue is just like sending it all slows it down. I mean, this is relatively good frame rate for what I'm trying to
So
do.
it's a memory wall issue here, right? You're trying to
Yeah,
feed
it's
the
transfer. I
graphics
think.
card too fast. Okay.
Well, I think it's just transfer time itself because I can't bulk send all of this. Just the way that, at least with the functions we learned in class, there is a cap on the number of vertex points you're allowed to send for drawing. But yeah, so I couldn't bulk send all of my data, but lost my train of thought. Yeah, so there's a couple of ways I could have done it, but it would have required doing a lot of math in the vertex and fragment shader, and it was a little bit outside of what I could find for documentation. So I was trying more to focus on actually implementing things we learned from the class, that sort of stuff, like actual graphics, visuals. Yeah. Any questions?
Yes, questions, guys? Okay, thank you very much.